In this video, I'll introduce you to the concept of pivoting your data and how you can accomplish this in Postgres. Generally speaking, in the world of databases and spreadsheets, pivoting refers to our ability to take row-based data and pivot it 90 degrees into column-based data. Here in Excel, I've mocked up a little example of what that sort of looks like. This is useful for aggregating data across different categories, especially when dealing with long tables that contain a lot of history. As an example, suppose we have a table of customers, items that they purchased, and the amount of each purchase. To keep it simple, we'll say that all the items cost $5. Now suppose we want to take that data and transform it into a pivot table where we can sum the amount that each customer spent on each item. Our goal is to return one row per customer and one item per column. This can be accomplished by pivoting our data set. For our practical example, let's return to the DVD rental database, where our first task is to count the number of films in our database for each of our 5 film ratings. So G, PG, PG-13, R, and NC-17. One way to do this using a method we've already covered in this course is to use a series of case statements. Let me show you how. We'll start with select from film, and then in our select clause we'll say count star as count all, then come down a line and say sum case when film rating equals G, then 1 else 0 end. Close the parentheses on that sum function and say as count G. Now we're going to take this line, copy it, and paste it 4 more times. 1, 2, 3, 4. And then we'll fill in the additional ratings below. PG, and then we'll say PG-13, PG-13, then R, and finally NC-17. Now that we have updated our case when statements and updated our aliases, we can run the query and look at our results. So this is a good approach, and it works across every variation of SQL. Postgres, Oracle, Microsoft SQL Server, the case statement is compatible with all of them. And this is how you can pivot your data across all of those platforms. Now in this course, we're using Postgres. And I would be remiss if I didn't show you one really cool feature of Postgres that actually gives us a little bit of an edge over some of the other variations of SQL. And it actually gives us a little bit of a shortcut. It involves using something called a filter clause, which allows us to accomplish the same thing we just did with our case statements, but in a slightly more streamlined way. I'll demonstrate. Let's come down a couple rows below our first select statement, and we'll say again, select from film. This time, we will again say select count star as count all. And then on our next line, we're going to once again say count star, but after the count star, we're going to say filter, open parenthesis, where film.rating equals G. Then close parenthesis and alias this as count G. Then copy that row and paste it 4 more times. 1, 2, 3, 4. Now do the same thing we did before and update the ratings on each row. Count PG, PG-13, R, and NC-17. Alright, now let's actually do a union all between our 2 queries and look at the results side by side. You can see that we get the exact same numbers with both queries. But using the filter clause in Postgres actually looks a little bit cleaner to me. It doesn't involve typing as many words, and it's actually pretty easy to interpret what's going on. So that's how you can pivot your data. The way to accomplish it across most databases is with case statements that are wrapped inside of aggregate functions, like we did here by wrapping the case statements inside of our sum functions. With Postgres, you can also accomplish this with the filter clause. In Oracle, Microsoft SQL Server, and most other variations of SQL, there is also a function called pivot, which can accomplish the same thing with a lot fewer words. Unfortunately, pivot is not supported in Postgres. There is an analogous function in Postgres called crosstab, but it requires installing another module on the database, which is less than ideal for this course. Instead, I'll stick to just teaching these two methods I've already shown you, and I'll leave it to you to research the pivot and crosstab functions outside of this course. Let's close out this video with one final exercise. Our goal is to figure out how popular certain film genres are with each of our customers based on the films they have rented from us. This is going to require us to reach across 6 different tables to get customer information, then the rentals, films, and film categories. It's really not all that complicated, but it just involves several table joins. Alright, that was a lot of table joins. So now let's go up to our select clause and let's add in customer.firstName, customer.lastName, and then let's go down and add a group by clause where we do the exact same thing, group by customer first name and last name. Now let's use the filter clause to get the count of the different genres that we want to analyze. We'll go down the line in our select clause and start with count, rental ID, filter, where category name equals action. Then close the parenthesis and we'll call this count action. Now let's copy that line and let's paste it below itself 5 more times. 1, 2, 3, 4, 5. Now our second category will be classics, so we'll say this is count classics. Next one is comedy, we'll call this count comedy. Next one is drama, which we'll call count drama. Then horror, which we will call count horror. And finally, my favorite, sci-fi. Now run this query and we get a table, a rather large table, 599 rows total, so 1 row per customer, as you recall from our week 2 videos. And we have all these columns that display the count of the number of films that each customer has rented across these different genres. Now, let's say that we want to find out who has rented the most sci-fi movies. We're going to say order by count sci-fi in descending order and run the query again. And we get 2 customers, Diane Shelton and Eleanor Hunt, who have both rented 7 sci-fi movies. And we can look across some of these other columns and notice things like Diane doesn't seem to enjoy drama or horror movies. We can then say order by count drama in descending order and see who are our biggest fans of drama movies. Apparently, Pauline Henry loves drama, cannot stand horror, cannot stand classics movies. So you can see how pivoting our data gives us this really cool analytical ability. We could take this data and then copy and paste it into Excel and do some visualizations on it to look at some overall trends or create a heat map visual. A lot of cool things that we can do with pivoting our data.